Welcome sa ating YouTube channel. Ang topic natin sa video na ito ay about sa solving first degree indeterminate trusses using method of consistent deformation. Paano ba natin malalaman kung first degree indeterminate yung truss natin? So, it's either kung sasabihin natin na first degree statically indeterminate, pwede siyang internally indeterminate, pwede rin siyang externally indeterminate. So, atong first example natin, first degree statically indeterminate ito. Externally. Why is it? Okay, let me read the question first. Determine the reactions and the forces in each member of the trusses shown. Mapapansin natin, yung reactions meron sa A na hinge. So, may vertical reaction doon. Yung component ng force may vertical reaction. Meron din tayong roller sa point C. Meron din sa point D. Siyempre, meron tayong horizontal reaction dun sa AH. So, kung mapapansin natin, sobra tayo ng isang reaction. Kasi kaya naman i-resist ng truss ito or kaya naman i-resist ng dalawang reaction to. Isang hinge at isang roller. So, ibig sabihin, kahit wala yung isang roller dito, either C or D, it is statically determinate. So, pipili tayo dyan sa tatlong yan or sa apat na ito ng magiging redundant, in which kapag tinanggal natin yung reaction na yon, still statically determinate yung truss natin. So, it's either tanggalin natin yung C or yung D, but for this example, tatanggalin natin yung reaction sa C. So, basically, tatanggalin muna natin yung roller dun sa point C. So, we're going to choose C as the redundant. But take note, later on, pabalikan natin yung compatibility condition. So, first, tanggalin natin siya, no? Ayan. So, ang mga titira sa atin ay yung hinge dun sa point A at yung roller dun sa point D. In this case, this is statically determinate. So, first, kunin muna natin yung mga reaction. We have this one and this one. Siyempre, may kukontrang 50 na pakaliwa dito. By summation of forces horizontal. By method of section or method of joints mo, kuha natin yung mga bar forces. Inuna kong ilagay rito yung mga bar forces sa horizontal members. Followed by the vertical members. And lastly, yung forces doon sa inclined members. So, nakalagay rito yung sense ng direction ng force, compression or tension doon sa member na yan. So, this is the primary truss subjected to external loading na wala yung reaction doon sa C. Next, we have this primary truss again, but we need to apply the redundant RC na tinanggal natin. Okay. So, ito po yung mga reaction. So, naglagay tayo ng unit load 1 for simplicity. Ito yung reaction natin. And then, kukunin natin yung mga bar forces or member forces. So, ito yung sa horizontal members, vertical members, and inclined members. But since this is just a unit load 1, hindi pa natin fully na ibabalik yung RC. So, lahat yan in magnitude, i-multiply natin nung magnitude ng RC, which is yet to find out. Hindi pa natin alam yan. Yun yung aim natin dito eh. Makuha muna yung value ng RC. Okay? So, balik tayo ron sa truss kanina na. Okay. So, tinanggal natin yung roller dun sa joint C. So, ibig sabihin, dahil originally may roller dun, it prevents that joint by translating vertically. Pero pwede siyang mag-move horizontally kasi nga roller siya. But the point here is, it cannot be moved from vertical position. Kasi nga yun yung purpose. Kaya nga may reaction na vertical. So dahil tinanggal mo, magde-deflect yung or magde-deform yung mga members. Therefore, madi-displace yung mga joints. In this case, magkakaroon ng vertical displacement yung point C. So, tatawagin natin siyang delta prime CV. Okay? Yung first subscript na C is to denote that it is from joint C, and yung second subscript na V to denote that it is vertical. Okay? So, for the redundant naman, kung nag-apply tayo ng unit load 1 dito na pataas, made-deform din yung mga members. Therefore, madi-displace din yung mga joints. But take note, i-multiply natin siya ng magnitude ng RC na yun yung aim natin dito. So, let's say, for example, ito yung kanyang displaced position. Magkakaroon tayo ng another deflection or displacement rather. So, in this case, tatawagin natin siyang delta double prime CV. Okay? Or, hindi po derivative yung prime dito, no? It is just to denote that it is not the original deflection or displacement. So, what is our compatibility condition? So, delta prime CV plus delta double prime CV must be equal to what? Delta CV o yung existing na displacement doon sa original structure natin. But since that is a roller, hindi gagalaw yun vertically dahil nga may doon, may restrained na roller unless there is a support displacement or support settlement, magkakaroon ng magnitude ito. Okay? So what is the value of these two remaining parameters? Delta prime CV is summation of SUL over AE, alam na natin yan, and delta double prime CV is equal to what? U squared L over AE times the magnitude of RC. Bakit U squared L over AE? Kumbaga, yun pa rin si SUL over AE, but since yung magiging S mo doon is si U rin mismo, so U times U is U squared. That's why we are going to use U squared L over AE. So, kagaya ng ginawa natin doon sa trusses, mas magandang gumawa tayo ng table. Okay, so say that delta prime CV plus delta double prime CV is equal to 0. So, yun yung ating magiging working equation. So, yung delta prime CV, nandiyan na yung value sa taas, and delta double prime CV, nandiyan din yung value sa taas. Okay. So, let's go to our tabulation. Okay. So, since constant naman yung cross-sectional area, ilagay natin siya as 4,000 square millimeters, nakalagay po yun sa given. Constant din yung modulus of elasticity na 200 gigapascals. Yung lengths respectively are as follows. And then, ilagay natin yung mga values ng forces and then the reactions also, pwede rin naman ilagay yon dito sa ating second column sa S. Take note, our sign convention, positive yung tension, negative yung compression. So as with the U. Alright? So you can pause the video if you need some time to observe this. Ito po yung mga values na nakuha natin kanina ron by method of joints and method of sections. So by means of SUL over AE, take note that the magnitude of S is kilonewtons, U is unitless, M is millimeters, cross-sectional area squared millimeters, and E, modulus of elasticity, kilonewton per square millimeters. So, consistent tayo sa units, matitirang unit ay millimeters. So, kuha tayo ng calculator. Pakita ko sa inyo kung paano yung una. Okay. Paano ito? So, we have 145.833 times negative 0.25 times 3,000 divided by 4,000 divided by 200. So, that's roughly negative 0.1367. Mas maganda kung gagamit kayo ng saktong values, no? Okay, balik tayo sa ating table. Ito po yan. Okay, and then the following can be solved using the same manner. Okay, then after which we are going to sum up the values, and then we get negative 2.29673. Okay, next we have U squared L over AE. Take note that the unit here is millimeter per kilonewton because U is unitless, therefore merong kilonewton sa ilalim. Okay, so same manner lang naman to. These are as follows. So obviously lahat to positive kasi kahit negative yung U, dahil naka-square yun, magiging positive unless 0 yung value ng U, katulad ng BE, 0 talaga siya. And then sum up the values, and then we have positive 0.011076. And balik tayo rin sa ating compatibility equation kanina, that delta prime CV plus delta double prime CV is equal to 0. Therefore we have what? Negative 2.29673 plus 0.011076 RC equal to 0. Okay, so by means of transposition and using algebra, we get positive 207.354 kilonewtons. So what is the indication of being positive? It means that RC is really upward based on sa application natin ng unit load 1 na pataas din kanina. Okay, to get the values of the bar forces and the reactions, we have what? Yung second column na S plus the product of the third column na U times the magnitude of the redundant RC na nakuha na natin as 207.354. So very careful tayo sa paggamit ng sign. Okay, we have 145.833 plus negative 0.25 times 207.354. So roughly that is 93.99. Okay, ginamit ko lang dito sa presentation natin ay sakto. So 995 yung nakuha natin na. So ganun din yung gagawin natin sa mga susunod na cells pababa. And then solve with the reactions. Okay, so here's our answer for this example number 1. Okay, so proceed tayo sa ating next example. Determine the reactions and the forces in each member of the trusses shown. In this case naman, it is statically determinate. Okay, externally. Because isang hinge lang tsaka roller yung ating support. Okay, so ibig sabihin, statically determinate siya. But, hindi po. Dahil sobra yung bar forces. We have a cross brace here. Yung AD tsaka BC. Which means, sobra yung members. Okay, ibig sabihin, it is statically indeterminate internally. Because it is what? Sobra siya ng isang member. Therefore, we need to select or choose one member to be the redundant. So that yung pag tinanggal mo siya, magiging statically determinate pa rin yung truss mo. So it's either you remove one of the cross brace here because ang trusses guys, kailangan may mabuo kang triangles. So it's either you choose BC or AD. So in our case, we're going to choose AD or force AD as our redundant. Take note, may mga reaction dito. Statically determinate siya kasi kayang-kaya mong punin yung reactions. Okay, kahit internally indeterminate siya. Okay, by summation of forces lang na yan, tsaka summation of moment. So we're going to select FAD or force AD as the redundant. Okay, so tinanggal na natin siya. So this is the primary truss subjected to external loading. So by summation of forces and summation of moments, makukuha natin yung mga reactions. Then, by means of this, kaya na natin kunin yung mga member forces. These are as follows. Okay? So next, primary truss with redundant force AD. So ngayon, hindi natin alam kung ano yung sense ng member AD. Either compression ba siya or tension. So in our case, mag-a-assume tayo ng sense niya, which is tension. So mag-a-apply tayo ng unit load 1 to both ends, point A and point D. Okay, magkasalungat yung dalawang yan. So therefore, by summation of forces, magkukontra yung dalawang yan, wala kang ma-induce na reaction dito sa mga supports. Pero magkakaroon ng bar forces yung mga members. These are as follows. This can be done using method of joints and method of sections. Okay? So, let's go to our deflected shape ng truss natin. Okay, remember, dahil nag-apply tayo ng unit load 1, hindi pa yan yung magnitude ng force AD. So, multiply natin siya ng mismong value ng force doon sa AD. Okay. So, this is our original truss. So, kapag binaklas natin yung AD, okay, take note na binaklas natin. So, definitely, dahil magkakaroon siya ng displaced position, technically, yung point D madi-displace greatly. Therefore, yung bagong position ng point D is mas malayo na ron sa point A. Therefore, mag-elongate yung member AD based on our assumption. Okay, so magkakaroon ng gap doon sa member AD kasi nga pinutol natin siya momentarily para magkaroon tayo ng force, para makita mo yung effect ng force AD. Okay, so magkakaroon ng gap doon sa member na yon. Kung ano man yung gap na yon, this is yet to be found out. In the next, by application of this unit load 1, okay, by 1 dito sa kabila, no? Let's say for example, ganito yung magiging deformed position or displaced position. So dahil nag-apply ka ng 1 on both ends, so magsasalubong naman yung member doon. Okay? They're subjected to force AD. So magkakaroon ng overlapping doon sa member na yon. Okay? So we will call this as delta double prime AD. Nag-overlap siya. Okay? But since wala namang gap or overlap na nag-exist dun sa original member AD, therefore we can conclude that the numerical value or the sum of these two deformations are equal to 0, namely delta prime AD plus delta double prime AD will be equal to 0. Okay, and then take note, same process dun sa kanina, delta prime AD is summation of SUL over AE, and delta double prime AD is summation of U squared L over AE. Okay? So, punta tayo ron sa ating tabulation. So, ilagay muna natin yung mga cross-sectional area. Take note na magkaiba yung cross-sectional area ng diagonals. Same lang ng modulus of elasticity. Be careful sa pag-input sa lengths. Then next, input natin yung mga member bar forces dun sa primary truss subjected to external loading, followed by yung application ng redundant FAD by unit load 1. Next, summation of SUL over AE. So, we have this 1. Okay, purong natin. We have 75 times negative 0.8 times 4,000 divided by 4,000 divided by 200. So this is negative 0.3. Okay. Then these are as follows. Then sum up natin. Same lang din yung gagawin natin sa U squared L over AE. Take note, nilagyan natin dito yung AD dito, no, with, syempre tinanggal natin siya, so yung bar force doon doon sa external loadings ay 0. Pero yung magnitude niya doon sa U ay positive 1 kasi nga nag-apply ka ng tensile force doon. In-assume natin na tension si AD. Okay? So proceed tayo kay U squared L over AE. Parehas lang naman ng process. Okay? These are the values. Lahat yan positive kasi U squared, no? Then sum up natin. Then apply the compatibility equation. So we have negative 0.4453125 plus 0.0191 FAD equal to 0. Therefore, we get FAD is equal to what? 23.315 kilonewtons. Positive po ito. Which means that force AD is really tension. Take note guys. Dahil positive yung value, tama yung assumption natin ng force or ng sense ng force dun sa AD which is tension. So, let us now substitute the values. So, katulad nung kanina, ito ay 56.348. Tingnan natin, no? So, we have what? Ano ba yung AB? We have 75 plus negative 0.8 times 23.315. So, tingnan natin kung halos parehas. Ayun. Halos parehas. Parehas nga naman talaga, no? 56.348. And then the following is this. Okay, then these are the reactions. Meron tayong shortcut dito sa calculator. I would like to show it to you, no? Nagamit tayo ng mode 3.2. But take note, kailangan naka-on yung frequency. So para i-on yung frequency, press shift set up, down arrow, then may stat dito. Frequency, tatanungin kanya kung on or off. So i-on natin. Po yung ilalagay sa Excel. Ang ilalagay po natin is yung S. Okay, so 75, 0, negative 43.75, negative 100, negative 93.75, 0. Then sa Y, yung U, negative 0.8, negative 0.8, negative 0.6, negative 0.6, 1, and then 1. Sa frequency naman, ang ilalagay po natin is L over AE. So, itong tatlong to. So, 4,000 divided by 4,000 divided by 200. Okay? Lagay natin sila, no? 3,000 naman to. So, 3,000. Then this one is 5,000. Pero yung area 5,000 din. Okay, check lang natin, no? Ay, wait. 5,000 divided by 5,000 divided by 200. Yan. Then press AC. Then press shift 1, 3, 5. So, ito po yung summation of SUL over AE without computing the values here. So, ito po yun. Parehas yan. Store natin kay A. Then, for U squared L over AE, we have shift 1, 3, 3 naman. Summation of Y squared. So, that is 0.0191. Ito po yun. So, store natin siya sa B. Then, the value of FAD is negative A over B. 23.315 kilonewtons. Okay? So, yung last column, kayo na po yung bahala dyan, no? Pwede mong i-store tong value na to dito. And then, we have what? Pakita ko yung una, no? 75 plus negative 0.8 times RC na in-store natin sa C. Ito po yun, 56.348, 16754. So meron pa yung mga values dun sa dulo. Ito po yung saktong value niya. So ito po yung example natin ng first degree indeterminate trusses. So dito po nagtatapos yung ating video. So don't forget to like, comment, share, and subscribe for more uploads para updated po kayo palagi. Thank you.